Welcome friends. We have seen the basics of graphs, and in this tutorial we will learn about application of graphs and algorithms. Applications of graphs. They are used in graph electronic circuits, that is printed circuit board and integrated circuit. Graphs are used in transportation networks, that is highway network, flight network. They are used in computer networks, local area network, internet and web, and databases, that is entity relationship diagram. Let us see some graph algorithms. The first one, that is Warshall's algorithm. A directed graph G with m nodes is maintained in memory by its adjacency matrix A. This algorithm finds the path matrix P of the graph G. Step 1. Initialize P. Repeat for I, j equal to 1, 2, 3 up to m. If A of I, j equal to 0, then set P of I, j equal to 0. Else, set P of I, j equal to 1. Step 2. Update P. Repeat step 3 and step 4 for k equal to 1, 2, 3 up to m. Step 3. Repeat step 4 for I equal to 1, 2, 3 up to m. Step 4. Repeat for j equal to 1, 2, 3 up to m. Set P of I, j equal to P of I, j or P of I, k and P of k, j. Fifth statement, exit. Now, the depth first search. A depth first search in an undirected graph G is like wandering in a labyrinth with a string and a can of red paint without getting lost. We start at vertex S, tying the end of our string to the point and painting S visited. Next, we label S as our current vertex called U. Now we travel along an arbitrary edge u, v. If edge u, v leads us to an already visited vertex v, we return to u. If vertex v is unvisited, we unroll our string and move to v. Paint v visited, set v as our current vertex and repeat the previous steps. Depth first search algorithm. This algorithm executes a depth first search on a graph G beginning at a starting node A. Step 1. Initialize all nodes to the ready state, that is status equal to 1. Step 2. Push the starting node A onto stack and change its status to the waiting state, status equal to 2. Step 3. Repeat step 4 and step 5 until the stack is empty. Pop the node n of stack, process n and change the status of n to the process state, that is status equal to 3. Step 5. Push on to stack all the neighbors of n that are in the ready state, status equal to 1 and change their status to the waiting state, status equal to 2. Step 6. Exit. Breadth first search. Like DFS, a breadth first search traverses a connected component of a graph and in doing so defines a spanning tree with several useful properties. The starting vertex S has level 0 and as in DFS defines that point as an anchor. In the first round, the string is unrolled the length of one edge and all of the edges that are only one edge away from the anchor are visited. These edges are placed into level 1. In the second round, all the new edges that can be reached by unrolling the string 2 edges are visited and placed in level 2. This continues until every vertex has been assigned a level. The label of any vertex v corresponds to the length of shortest path from S to v. BFS algorithm. Step 1. Initialize all nodes to the ready state, that is status equal to 1. Step 2. Put the starting node A in queue and change its status to waiting state, status equal to 2. Step 3. Repeat step 4 and step 5 until queue is empty. Step 4. Remove the front node n of queue, process n and change the status of n to the processed state, status equal to 3. Step 5. Add to the rear of q all the neighbors of n that are in the ready state, status equal to 1, and change their status to the waiting state, status equal to 2. 6. Exit. So this was all about graphs. Thank you for watching the tutorial.